Welcome back. In this video, we're continuing with two categorical variables in a contingency table, and we're going to do an independence test. So we want to know often if two variables are related or connected to each other. Are they independent from each other, or is there a relationship going on? Okay, so we're going to use the conditional probability that we were just looking at, use conditional probability to determine this. And we've done something similar in an experiment with the stent, so it might look familiar to you, but we're going to make it a little bit more formal this time. So the conditional probability is written if B given A, and A is the given piece, right? So if that's really close to the probability of B, then that means knowing A did not affect, this given A didn't affect the probability of B occurring. So if A doesn't affect B, then they're independent from each other. Okay, so if knowing A doesn't affect B, they're independent. So that's where this statement comes from. So this, and it's written out in words here too, this means that knowing event A occurred does not affect the chance of B occurring. Okay, so we're using mostly empirical data, and here we're using empirical data. If we were doing theoretical probability, then I would have an equal sign there. For theoretical probabilities, then if the two sides are equal, then they're independent. Okay, but with real data, we always have variation, and so we would never expect probabilities to be exactly equal. So that's why I'm saying approximately equal with the squiggly equal sign. Approximately equal. So with empirical data, the two sides of this equation, these two probabilities, would rarely be exactly equal. But if they're close, they're independent. If the two sides are significantly different, they are dependent. Okay, now how far away is significantly different? We don't know that just yet. So either way, whichever way you decide, explain your reasoning so that your reasoning is clear, and then either answer is okay as long as your reasoning matches that, okay? Note, this is kind of a basic test for independence, just to get the concept. There is a more formal test that's in Math 244 or Stat 244. So we're not using the entire table, and so you might be wondering, well, that seems funny, but it's because this is a sort of an introductory test. Okay, so we have this data table from our experiment that we've been looking at for a treatment for cocaine addiction. And there were three groups, disipramine, lithium, and placebo, which are in the rows. And then the results were recorded, whether someone had a relapse or did not have a relapse. And then the totals. Okay, so what we want to do is look for, this formula can be kind of challenging, so I'm going to do it intuitively first and then show you how it fits with the formula. So you don't have to use the formula unless you want to. What we want to look for is one of the results. Okay, relapse or no relapse. I'm going to go with the more positive one, no relapse, because that's a little easier when higher is better. Right, so this is the positive result. Result we would want is for someone to not start using cocaine again, so to not have a relapse. And then we're going to compare that percentage in each group. So you'll see in a moment that this is a conditional probability. So I'm going to take 14 out of 24. I'm going to show you the pattern and put it in different colors. So I'm circling 14 out of 24 in pink and 6 out of 24 in purple. And then for placebo, we have 4 out of 24 in green. And I do have one more color, but it's black. But I'm going to do the total of no relapse is 24 out of the grand total is 72. Okay, so what I'm going to do is compare these probabilities. 14 out of 24, and I'm going to put equals. I could put equals or approximately equal with a question mark over the top. So it's really a question. Are these close? 6 over 24. Is that close to 4 out of 24? And then our overall is really like the average. Is that close to 24 out of, oops, 72. Let me fix that real quick. 24 out of 72. So sometimes you might do this going down, and sometimes you might do it going across. It depends on which way makes more sense in a particular table, the way the table is set up. So let's go ahead and divide these and see. So this is essentially the success rate in each group, right? And because we're using our row totals, that's a conditional probability. So 14 out of 24. You won't always have the same denominator, but in this case they were exactly equal, so we can tell which is higher, and it looks pretty significantly higher, doesn't it? Okay, get my right color here, 0.5833. Oh my gosh, okay, I can't write. Let me start over. 0.5833. 0.5833, and then 6 out of 24 is 0.25, a quarter. 4 out of 24, success rate in the placebo group, that's 0.1667. So we were saying in the last video that's not very good. And 24 out of 72 altogether who didn't have a relapse. That's a third chance, 0.3333. So I haven't written the symbols in between because I'm kind of waiting to look at the numbers and decide. Do these seem close to each other, or do they seem significantly different? And keep in mind, this total one is always the average, so it should be in between the other, somewhere in between the other numbers. So it does look to me like there's a very significant difference, right? The folks who took dicipramine had a 58% success rate. Lithium, so maybe they're testing lithium as a new type of treatment for cocaine, and or maybe it's treating an underlying depression, since they said it was an antidepressant. So it does look promising in this small study, right? 25% success rate with lithium, only 17% success rate in the placebo group, and overall a 33% success rate overall. So it seems very significant. So I'm going to say that these are approximately equal to, or sorry, I'm going to say they're significantly different from each other. So I'm going to say they're not, you could say not equal, or I'm saying they're not close to each other. That's what the slash through means. Okay, so let's write out the conclusion, and I'll show you if you're interested in the probability statements of that conditional rule that I wrote out first. Okay, so to write a conclusion, I mentioned you need to say your reasoning. So I'm going to write out the probabilities are significantly different, or I could say the success rates. That puts it in a little more context. Success rates are significantly different. So not having a relapse is dependent on the treatment given. Okay, so sometimes you might say, you can say dependent. Oops, let me move this up. Or you can phrase it as not independent. Those mean the same thing. So, but dependent, I kind of like, because dependent goes with different. And not independent is close. Or actually, those mean the same thing. Dependent or independent is close. Dependent is different. So I like to remember the D's. That helps me. Okay, so I picked one of the rows or columns, one variable, and then divided by those totals. So please do show, when you're doing one of these, show the numbers you're dividing, because we could have picked the relapse row, right? It's just then we would have been looking for lower would be better versus in this one higher would be better. So show what you're dividing. That way I can check that it's a valid pattern, because there's many valid patterns. And I believe that for these two variables to be independent, it has to also work across might have to work across the row and the column. So let me show you what the probability statements would look like, okay? Which you don't have to write out, but you can. So this one, what we found up here is the probability that the person did not have a relapse. So I'm going to write NR given D. Person did not have a relapse given they were in the disipramine group, okay, because we were only using that row. And then the lithium row is probability not having a relapse, so NR given L. Similarly, the placebo row is the probability of not having a relapse given P. They're in the placebo group. And then this last one is the probability of not having a relapse, just period, because it's the total, it's the marginal probability not having a relapse. So think of this as the probability of NR given D, or L or P is the same, is that the same or close to the probability of not having a relapse? So that is just like how this formula, probability, this would be NR given D, L, or P, is that equal to the probability of NR? Okay, so it's the first two that are matching, or the first one and then the probability by itself. Okay, great. So if that helps, you're welcome to use the probability statements, but you don't have to. You can do it out intuitively from the table, okay? Just practice the pattern a few times. And in the next video, I'll have a practice video, practice problems that we'll go through one more example. Okay, see you in the next video.